Okay, so the next one is the Katz centrality. Okay, so what the Katz centrality is does. Katz centrality is came on drawback of the eigenvector centrality. So eigenvector centrality is passed only if there is an outgoing edge. Eigenvector centrality need an outgoing edge. For example, if a node in a directed cyclic graph, the centrality will be 0 even if there are many edges connected to the node. That means if I'm having this kind of a directed graph, if I'm having this kind of directed graph, okay, but if we are not having any kind of outgoing edges in the graph, then the whole centrality of this network is going to be 0 even if there is a connection in between the nodes. Okay, many connection in between the node. If there is no any outgoing node, then the centrality is going to 0, and that is the drawback of the eigenvector centrality. So the Katz centrality came in picture, and it nullify this problem by adding the bias. That means beta. So we are just going to add a beta in this formula. Okay, so here is the formula. The Katz centrality equals to alpha A transpose Katz centrality plus beta. We are just going to add the beta factor here for as a bias. Okay, so that's the Katz centrality.